Hello everyone, myself Suma chitragar. I am studying in 10th standard at Adarsha Vidyalaya school, Badami Taluk, Bagalkot district. Today I am discussing on science lesson periodic classification of elements. In this session I am going to discuss on two topics. First one is Dobereiner Triads and second one is Newlands law of octaves. So the subtopics of this session are: first one is merits of Dobereiner Triads, second one is limitations of Dobereiner Triads, third one is merits of Newlands law of octaves, and fourth one is limitations of Newlands law of octaves. Before going to start this session, we have to learn some points so that we can understand this session easily. Matter around us is made up of elements. The discovery of these elements is an ongoing process. At present, there are 118 elements in the earth, out of which 94 are naturally occurring and remaining 24 are synthetic. In these days, we can see this modern periodic table. But in olden days, before the preparation of this modern periodic table, so many scientists were worked for the correct and proper arrangement of elements. When scientists found that several elements share similar properties, they tried to classify them into groups to study them more easily and systematically. And they proposed their own methods to classify elements known at that time. Johann Wolfgang Dobereiner was the first scientist who attempted to classify elements based on their atomic weights by grouping elements into triads. John Newlands was the second scientist who classified elements on the basis of the atomic weights. He arranged elements up to 40 atomic mass, which means John Newlands arranged elements up to calcium. And some other scientists like Dmitry Mendeleev and Henry Moseley made a great achievements for the preparation of the periodic table. But in this session, we are only discussing on Dobereiner Triads and Newlands law of octaves. So let's start this session. The first topic of this session is Dobereiner Triads. In 1817, Johann Wolfgang Dobereiner, a German chemist, attempted to classify elements on the basis of their properties. He proposed the law of triads, which states nature contains group of 3 elements called triads, which later came to be known as Dobereiner triads. So what is Dobereiner triads? The physical appearance and reactions of the elements in each triad are similar. In each triad, when elements are arranged in the increasing order of their atomic masses, the atomic mass of the middle element was approximately equal to the average atomic mass of other 2 elements. For example, in the triad containing lithium, sodium and potassium, the atomic mass of sodium is equal to the average atomic mass of lithium and potassium. So these are the 3 triads which were proposed by Dobereiner. He arranged the elements in increasing order of their atomic masses. The elements of the first triad are lithium, sodium and potassium. The atomic mass of lithium is 7, sodium is 23 and potassium is 39. By Dobereiner triads, when we add the atomic masses of first and third element of a triad and divide it by 2, why we divide it by 2? Because we are calculating the average of first and third element. By dividing, we can get the atomic masses of the middle element in a triad. So take the first triad as example. Here we add the atomic mass of first and third element in that element, that is 7 plus 39, and divide it by 2, we get 23. So this is the atomic mass of the middle element in a triad, that is sodium. So second one, the elements of the second triad are calcium, strontium and barium. Here the atomic mass of calcium is 40, strontium is 88, barium is 137. Here we add the atomic mass of the first and the third element and we divide it by 2, we get 88.5, that is approximately equal to the average atomic mass of the middle element in the triad, that is strontium. And the elements of the third triad are chlorine, bromine and iodine. The atomic mass of the chlorine is 35.5, bromine is 80, iodine is 127. Here we add the atomic mass of the first and third element, that is 35.5 plus 127, and we divide it by 2, we get 81.25. That is approximately equal to the average atomic mass of the middle element of a triad, that is bromine. So merits of the Dobereiner triads. So what are the merits of the Dobereiner triads? Dobereiner's method gave a hint that atomic masses can be used as a criterion to classify elements. Limitations of the Dobereiner triads. Limitation means restrictions. So what are the restrictions of the Dobereiner triads? First one is, a large number of similar elements could not be grouped into triads. For example, iron, manganese, nickel, cobalt, zinc and copper are similar elements but could not be placed in the triads. So second one is, even quite dissimilar elements could be grouped into triads. Third one is, Dobereiner could identify only 3 elements known at that time. Several elements were left out. Hence, this method was not successful. By these restrictions, the Dobereiner's method was not successful in the preparation of periodic table of elements. So let's know about Johann Wolfgang Dobereiner. In 1817, Johann Wolfgang Dobereiner, a German chemist, was the first scientist attempted to classify elements. He made the first observation on platinum as a catalyst and discovered similar triads of elements, which led to the development of the periodic table of elements. So the next topic of this session is Newlands law of octaves. John Newlands, an English scientist, picked up the hint that elements can be classified according to their atomic masses from Dobereiner and proposed the method of classification of elements. Highlights of Newlands classifications. So what are the highlights of Newlands classification? The 56 elements known at that time were arranged in the increasing order of their atomic masses shown in this table. Here we can see this table. This is prepared by Newland. He arranged the elements on their increasing atomic masses. So what is Newland's law of octaves? Newland proposed that just like a musical note in which the 8th note is same as the first one, every 8th element has the properties of the first element when they are arranged in the order of increasing atomic masses. He called this as the law of octaves, and this later came to be known as Newland's law of octaves. Merits of Newland's law of octaves. So what are the merits of Newland's law of octaves? Elements like lithium, sodium, potassium, fluorine, chlorine, oxygen, sulfur, beryllium, magnesium, etc., which were similar, were placed close to each other. Thus, the law of octaves worked well for the elements with lower atomic masses. Limitations of Newland's law of octaves. So what are the restrictions or limitations of the Newlands law of octaves. First one is Newlands law of octaves could be applied only till calcium. After calcium, every eighth element did not possess the properties of the first. Thus, the law of octaves failed for elements with higher atomic masses. Second limitation is Newlands assumed that only 56 elements existed and left no blank space for the possible elements that could be discovered later. Several elements discovered later could not be arranged as per this octave pattern. When new elements were discovered, he put two elements at the same place. For example, cobalt and nickel were placed in the same slot. Here we can see in this Newlands table, he put two elements in the same slot. Example, here he put cobalt and nickel in the same slot, and ruthenium and rhodium in the same slot, and cerium and lanthanum in the same slot, and platinum and iron in the same slot. So the fourth limitation is, unlike elements like fluorine, chlorine, bromine, which have different properties than cobalt and nickel, are placed in the same columns. Example, here fluorine, chlorine, cobalt, nickel, bromine. Here we can see in this table, fluorine, chlorine and bromine have different properties than cobalt and nickel, but Newland placed them in the same slot or same column. So the last and the fifth limitation of Newland law is elements having same properties are placed away. Example, iron element resembles in its properties with cobalt and nickel, but iron was placed away from these elements. Here we can see in this Newlands periodic table, iron resembles in its properties with cobalt and nickel, but Newland placed iron away from these elements. Here we can see iron is in the last column and third slot, but cobalt and nickel were in the first column. So, therefore, by these reasons, the Newlands law of octaves was rejected. By these restrictions, the Newlands law of octaves was rejected or failed. So, let's know about John Newlands. John Alexander Rayner Newlands was a British chemist who worked concerning the periodicity of elements. In 1864, he published his concept of the periodicity of the chemical element, which he had arranged in the order of atomic weight. He pointed out that every eighth element in his graphing shared a resemblance and suggested an analogy with intervals of the musical scale. Thank you.